people used to fly for a business meeting or a 90-minute workshop to New York. I don't think that's where we should go back to. Now people have more confidence in those vaccines and they're actually looking forward to get them. And that's a good sign. And we have to raise our children with much more environmental consciousness, right? I think those are really the key things for the future.
We are super excited for our listeners to join us today for the inaugural Chat Together podcast in what will be an ongoing series related to the way we come together as a society. As we all know, this has changed a great deal over the last year. We've gone from a world of face-to-face relationships to a world of virtual relationships. Chat Together will address how people come together now and what we believe the future holds. We'll look at how technology might be a solution to help us come back together faster. I'm 𝗪𝗪𝗶𝗀𝗪 and I'm the CEO of Come Together, who was founded to address event ticketing challenges with the power of blockchain. With no events in 2020, we used the blockchain foundation that we had built to address those event ticketing challenges, and we developed Back Together. Back Together is a COVID-19 passport app to help us bring us safely back to a world of face-to-face contacts. Join us for discussions about topics from technology and especially blockchain to event ticketing, immunity, and more. Today, I'm delighted to have Claudia Schaller joining me. Claudia has a diverse background combining life sciences and entrepreneurship. She's the founder of Finfutura, an organization that builds ventures, consults, and conducts research in the health, food, and tech sector. For many years, she was in Silicon Valley, working with US-based innovation consultancy and completing her PhD in immunology, conducting medical research at the University of California, San Francisco. Today, we will focus on the topic of COVID-19 and the work Claudia has been doing related to this topic. Could you start by telling us a little bit about yourself, Claudia?
Yeah, thank you so much for that nice introduction. And thank you for the opportunity that I can talk about my favorite topics. And that's the immune system, it's the current pandemic, and potential future pandemics. So as you just mentioned, I'm an immunologist by training. That means I studied biology and then I focused on immunology. And I keep joking that since the current pandemic, people actually know what an immunologist is. Because seriously, believe it or not, like sometimes before people look at me with those big question mark in their eyes and they would be like, what did you study? So I'm happy people know now a little bit more about the immune system and the value of immunologists that currently are doing an amazing job, right?
Absolutely.
So after I got my PhD, I moved on to an innovation consultancy, as you just mentioned, and worked with great Silicon Valley clients. And for me, most importantly, I was able to gain a different skill set. So on top of my scientific knowledge, I was now able to consult people about innovation. So after being 15 years, and that's a quite long time in the US, I decided I have to move back to my native Germany. That's a couple of years ago. And then I founded Infutura here. And as you already said, Infutura really brings together those both worlds of life science and innovation. And we have great clients and we help them reach their next level. And besides this, I also run a startup accelerator. It's called Founder Institute Munich. It's a very early stage startup accelerator. So people come to us, they just barely have an idea about their startup, and we help them validate and help them to incorporate and guide them towards funding. Yeah, so that's what I'm doing.
So from research to more towards the market now. So what are you working on currently specifically?
Well, I have quite a few really exciting clients. And I have to say my favorite client currently is the Human Vaccines Project. And what they are doing, they are trying to decode the human immune system. And as you probably know, the human immune system is A, very complex, and it's B, very, very diverse. And if you really think about it, until now, we haven't been able to answer the most fundamental questions about the human immune system. And that's, for example, why some people get sick and others don't get sick. And with COVID-19, we can clearly see this, right? We have people that are asymptomatic. We have people that have very mild disease, people with severe COVID-19, and then some people even die of it. And so what the Human Vaccine Project does is really trying to understand how the immune system functions in health and also in disease. And that will enable everyone to come up with better vaccines and better therapeutics. And I do believe that this has a huge impact on humanity because it will really, really change human health on a global level. And what I also like about the Human Vaccines Project is it's just there are amazing people behind it, like the world's best researchers, Nobel Prize laureates. But all of them are very, very humble. And it's really, they really love what they are doing. And they have a great founder story because one of the founders, actually, he used to be one of the best HIV vaccine researchers. So he spent all his life, he dedicated his life to finding an HIV vaccine. And as you probably know, there is no HIV vaccine, right?
Yeah,
there isn't one yet, right? And a little side note, HIV is a very, very tricky virus. So it's not that easy to come up or develop a vaccine for that virus. But at some point, he realized he failed, right? And he has to take a step back and first try to figure out how the immune system functions. And then everybody can come up with better vaccines. And that's how the Human Vaccines Project basically was born. And for me, it's this great story where, big roadblocks and obstacles were taken and turned into opportunities.
Yeah, indeed. And you said that the immune system is highly complex, and this is why it's so hard to develop vaccines. So could you explain the immune system a little bit better?
Yeah, so again, the immune system is fascinating, and, I'll be only able to give you a very, very simplified overview of it. So,
yes, please.
Otherwise,
I wouldn't like to dive way too much into it.
The main task is, of course, to fight infection, right? It also plays a big role in recognizing precancerous cells, but let's just focus for now on this main task of fighting infection. So that means the immune system has to be able to recognize every possible invader that exists or will exist. So every possible pathogen that's out there, right? And just let that sink in for a second. Every possible pathogen, right? And in case of SARS-CoV-2, that's a new pathogen. And your immune system also has to be capable of recognizing that. So the big question is how, right? How can the immune system do that? And the immune system has two main players. And I'd like you to think of it as the two main soldiers the immune system has. So those are the T cells, and then we have the B cells. The B cells are the ones that actually produce the antibodies. And on the surface of those cells, there are little receptors. And those receptors have to recognize the pathogen, or to be more precise, a piece of the pathogen. So in order now to be able to recognize every piece of any possible pathogen out there, we have to produce tons of different receptors. To be precise, we have to produce trillions of different B and T cell receptors. That's a huge amount of receptors. And then only when the right receptor binds to the right piece of the pathogen, so that's like a key that's finding its lock, right? Then that one cell gets activated and it turns into what's called an effector cell and multiplies. And to come back, so basically that the one soldier then becomes this huge army that is equipped with the perfect weapon to fight that disease. And I think that kind of explains a little bit why it's so complicated to decode it, because it's so immensely complex. The immune response is so complex. And then also the immune response between, let's say, the two of us can be completely different. So it's very, very diverse across populations. And as a quick reminder, I don't know if you had biology or so, we only have 30,000 genes, right? But now we have to come up with trillions of different receptors. So what's the mechanism behind that, right? So in that case, we have certain immune gene segments, so little slices, right, that code for those receptors. And those gene segments, they just get randomly recombined, rearranged, and on top of it, diversified. So think of it as playing lottery or shuffling cards, where you always come up with a different set of numbers or with a different set of cards. And that's really the mechanism how the body is capable of developing those trillions of different receptors to then finally have one that is capable of recognizing that piece of the pathogen and then turn into this army of effector cells. So I hope that was a little bit clear, or, the point came across how complex and diverse it is. And what I want to say with this, it explains why it's so hard to decode it, because it's hard to really understand what are the underlying principles and rules of the immune system. So what has to be done now, yes, you have to look at one person's immune response, but you also have to look at 1,000 more people's immune responses. You have to do what's called those large-scale studies across populations. And that, of course, generates a huge amount of data, right? And this is really now where AI and machine learning comes into play, because you need to be able to analyze this huge amount of data and identify the pattern that is behind it. So in other words, for example, why some people get sick or don't, what we call disease susceptibility. And that also kind of explains why we really haven't been able to decode the immune system, because those like AI and machine learning, those are pretty recent tech tools. Yeah, and the question is, so now what is the result? And the result really is, once we completely understand how the immune system functions, we will really be able to develop better vaccines and also better immunotherapies. So that is really, really the goal across any disease, for cancer, for any infectious disease. And also in terms of the current pandemics, we will be able to respond much faster to any pandemic. And that has a huge impact on human health, as we know. And in my opinion, we have to be really fast, because we are at the beginning of a global health crisis currently.
Okay, can you elaborate on this? So what does it mean that we are on the beginning of a global health crisis?
Sure. So first thing I want to say, I'm usually a very optimistic person. I really like to look at the bright side of things. But if you look at the current data, it doesn't look good for us, to be honest. So one reason why we are at the beginning of a global health crisis is we have this rapidly aging population. So it's predicted that by the year 2050, 1 in 6 will be over 65 on a global level. And if you look at certain countries right now, like Germany is a good example, or Japan, already 1/3 of the population is over 65. And now you might wonder, why is that such a big problem? It is a big problem, because once you get older, we see this steep incline in what's called non-communicable diseases, like cancers and Alzheimer's. And then you probably also know, once you're older, you're just much more susceptible to any infection. Again, COVID-19, great example. Once you're over 80, your mortality is basically skyrocketing. influenza is another good example, right? Older people die of influenza, or just any simple cold can be really hard on someone who's older. And that's the reason for that is that your immune system is aging as well. That's called immunosenescence, and it's actually a pretty new area of research. So in the future, it will be tremendously important to protect this older population. And, at some point we will be old as well. So we want to be protected. And then the second, for this podcast, more relevant reason is why we are at the beginning of this global health crisis is because we will see a rise of pandemics. And as I always say, COVID-19 is really just the beginning. So I say it's a dry run for what's yet to come. And the reasons is because, the main reason is climate change and a couple of other man-made factors.
Whoa, okay. That sounds a bit scary, but it's also super surprising that climate change impacts pandemics. So could you elaborate a bit on how does this happen?
Yeah, so it's a fascinating topic, and not a lot of people are aware of it. And maybe last week there was this climate crisis summit where a lot of leaders summoned and they talked about climate change. And I think it did raise a little bit more awareness around the topic of climate change and pandemics. But for most people, like, COVID was a huge surprise. They were like, oh my God, this pandemic is hitting. But if you look closely at scientific publications or are a little bit involved with the scientific community, then you know that they have predicted a pandemic like COVID-19 for years, right? And if you ever have time, I can give you a really good book recommendation, and that's called The Coming Plague. And that book is written by Laurie Garrett. She's one of the world's best scientific journalists. And she wrote that book in 1994. And in 1994, she predicts all these newly emerging diseases. So again, nothing new. We had a lot of warnings. And as I said, like, one of the main reasons is climate change. But there are a bunch of other reasons, right? It's like global trade, it's international travel, very important, it's loss of biodiversity, it's consumption of foods we're not supposed to eat as humans. Then there's something that's called encroachment into animal habitats. So that means we're more and more in areas where we're just not supposed to be. And that the consequence is we have more contact with wildlife, and of course overpopulation and urbanization, and some of those are of course connected with each other. So to be honest, it really never has been a question if a pandemic hits. It was the question when will it hit? Yeah. And there were clear warning signs because we had so many disease outbreaks over the last decades, like HIV, Ebola, swine flu, Zika, and of course SARS and MERS. And those were flashing warning signs, and they were not taken seriously enough. And if we would have done more pandemic preparedness, we could have certainly avoided the severity of this current pandemic. And I just looked up the numbers, and it's really awful. So we have until now 140 million cases of COVID-19. That's the entire population of Russia. We have more than 3 million people that died of COVID-19. And we have those trillions of dollars of economic loss. So yeah, if we would have been prepared for this, it would have been a good thing. And then if you look a little bit more closely at climate change, the status right now is climate change is already there, right? So we already see the effects, and we already see the effects on our health as humans. So what do we have? We have extreme heat, increased flooding, we have droughts, we have crazy wildfires, and because I lived for such a long time in California, you know, I witnessed those wildfires, and that's just devastating. Or if you look at the Australian wildfires in like early 2020, it's like 18 million hectares of land was just destroyed. That's the entire arable land of France, and human fatalities. Yeah.
Sorry, I'm really familiar with them because it's also every summer in Greece. It's we always have wildfires. It's something.
Yeah, yeah,
and this is the norm. Yeah,
it's awful. It's so devastating. And to come back a little bit to the diseases, so because of global warming, we see a spread of what's called vector-borne diseases. So those are diseases that are carried by a vector, for example, a mosquito. And what are those main diseases? Are dengue fever, Zika, and malaria. And now, because of global warming, the mosquito can expand its habitat. And that means million and million of more people are now affected by those diseases. And then let's talk also about flooding, because that's also quite interesting. So because of climate change, we have a higher intensity and frequency of hurricanes and typhoons. And with those flooding comes outbreaks of cholera and typhoid. And those are just very, very serious gastrointestinal diseases where people actually die of. Yeah.
All right.
No, not very positive, I know.
No, but I mean, it shouldn't be surprising. As you said, every less than 10 years, we had a new virus coming up. It was eventual that some of these viruses would be a more transmissive one, like SARS-CoV-2 didn't turn into a pandemic. So we should have been better prepared, and let's hope even now we are for some next pandemic that might be occurred. And which virus would you think could cause next pandemic?
Well, we have plenty to choose from. So there are a few good candidates out there, to be honest. Well, first we have to differentiate between viruses that are already out there and are able to infect humans. And then the other big group is viruses that through mutations gain the ability to infect humans and cause a disease outbreak or a potential pandemic. So those are kind of two groups, but from both groups we have plenty to choose from. So maybe one good story is the story of the chikungunya virus. And I know it has a crazy name. So that virus is causing high fever and really, really severe joint pain in people. And it's not a new virus. It has been around for quite a while, and it already has caused outbreaks in Asia and in Africa. But then a few years ago, what was surprising, there was suddenly an outbreak of that virus in Italy. So now the question is, how can that happen, right? So that virus is carried by the tiger mosquito, and the tiger mosquito usually likes to live in tropical areas. It likes to have it warm. And because of global warming now, that tiger mosquito was able to expand its habitat to the northern hemisphere. So now we find a tiger mosquito in Italy, we find it in France, we find it even in Switzerland. I don't know about Greece, actually.
We have it.
You probably have it. I think I heard that it's already in Germany. So what has caused that disease outbreak now is in Italy is quite interesting, because you need to have still a patient zero, right, that brought the virus to Italy. So there was someone who had traveled to India, got bitten by a local Indian tiger mosquito that carried the virus. So the person was then infected with the virus. That person traveled back to Italy, got bitten by a local Italian tiger mosquito that basically picked up the virus from the blood of that person. And then that tiger mosquito just went on and infected other people. So, and for me, it's an interesting story because there are many factors play a role for that disease outbreak, right? We have global warming. So the tiger mosquito was able to spread to Italy. We probably had the reason why the tiger mosquito was initially in Italy was probably because it was at some point imported for the import of global goods. And then the third factor is actually international travel. And that's a big factor for spreading a disease. Yeah. So that's just, I just find it an interesting story of how a disease outbreak can happen. And like the chikungunya virus, there are tons of more viruses out there that could cause the next disease outbreak. And I can recommend actually a really good website. And the website is Gavi, the Vaccine Alliance. And they have a whole section where they talk about what could be the next outbreak, what virus could cause the next pandemic. And another virus I want to mention is the Nipah virus. It's also not a new virus. It already circulates in Southeast Asia. It's already there. It's pretty dangerous because 3 out of 4 people die of that virus. So it has a very high mortality rate. People get this type of encephalitis and then they fall into coma and die. And this one is carried by a fruit bat. And fruit bat come quite often in contact with humans. And then that virus or the bat infects the human, and then the human spreads the virus. So, and the reason I'm telling this is because I want to talk a little bit about bats. So bats are really, really interesting animals. And unfortunately, they play a quite important role if it comes to newly emerging diseases. And we know they have contributed to COVID-19. You probably heard about it, that SARS-CoV-2 emerged in bats, jumped to an intermediate host, and then jumped over to humans. So we're moving now in the area of what's called interspecies transmission. So we're now starting to talk about the viruses that live already in animals, but gain the ability to jump over to humans. And as I said, bats play a fairly big role with this. And I really want to be careful, because bats are amazing animals and we need them. They're very important for our ecosystem. So this is, I don't want to cause fear of bats. I just want to look at this from a very rational scientific point of view. So bats just have the ability to host viruses, right? In particular, coronaviruses. And their immune system is fascinating because they're just resistant to those pathogens. So they're just those reservoirs, basically, with all those viruses. And then what can happen is that the virus mutates inside the bat and gains the ability to jump over from the bat to humans or to some other animal. And that is what's called interspecies transmission. And that is also now more likely because of that, what I said earlier, we have this encroachment into animal habitats. So we have more contact with wildlife. And then with bats in particular, bats are just really good in adapting to what's called anthropized environments. And you probably have seen this, bats, they can live in older houses or barns or under bridges. So that just increases the likelihood that we come in touch with them, actually. So if we look a little bit more closely at those interspecies transmission, so what we currently know, there have been already over 250 viruses that have jumped from an animal to humans and caused disease. Again, SARS-CoV-2 latest won't be the last. And the other thing we know is that there are probably around 1.7 million undescribed viruses out there, and 50% of them, those are 850,000, have the potential to jump over to humans. So just let that settle for a second. And that's called a spillover event. So it spills over from the animal to human. And there's actually also a great website out there. It's called Spillover, and scientists plug in those viruses, those undescribed viruses, and they rank them according to their potential to have a spillover event to humans. So that could be very interesting for you to check out, actually.
All those 800,000?
I mean, not yet. They're working on it. That's now a serious area of research, actually, to look at animals. What viruses do they host? And what viruses can actually then jump over to humans? And the coronavirus in particular is very likely for such spillover events. And that's just because coronaviruses are very, very common. They're very diverse, have a large host breadth. The fact that they are RNA viruses plays a big role, and they can recombine. So now if you would ask me what is my best bet for the next pandemic, yes, it could be another coronavirus. That's very likely in my opinion. Or I would also bet on influenza, on the flu. And let's not underestimate it. The next flu pandemic could easily kill millions of people in a quite short amount of time.
Yeah, as it did in 1918, the Spanish flu. So yeah, this with the bats explains a lot of questions that I had before. And how can we deal with these global pandemics? How can we keep some normalcy?
Yeah, that's a really good question. And I think we first have to define what is normalcy, right?
Great point.
So we really go back to where we were before? I don't think so, right? And like, for example, people used to fly for a business meeting or a 90-minute workshop to New York. I don't think that's where we should go back to. But of course, what we have to go back to is, that we are able to meet and gather and, be together with our communities. That is super important at this point of the pandemic. What is certainly clear at this point is that we're in for the long ride with COVID-19. And at this point, it's so super important that we bring back that normalcy, what we just talked about. And one way to do that is, of course, to have those really good vaccines and get people immunized. But the other way to do that is with developing cutting edge tech tools, right? And that go hand in hand and bridge the gap until everybody is vaccinated. And that's really where companies like yours come into play. And that's why this is so amazing what you guys are actually doing.
Okay.
So what's important to point out, if you come back to the vaccines we have, is that not everybody actually wants to get vaccinated. And getting a vaccine should always be optional, right? A vaccine Absolutely. in the end, if you really look at it, it's an intervention on a healthy person. So people should have the freedom to choose if they want to take it or not. And there will always be people who don't want to get vaccinated. There's a term for this. It's called vaccine hesitancy. And they just don't believe in the vaccine, are afraid of side effects, or don't believe in science, or, even in some countries, there might be a stigma around getting vaccinated. So, that is called vaccine hesitancy. And that means you can have the best vaccine on the market. People have to trust it and believe that it's protecting their health and actually get immunized. And we saw that vaccine hesitancy when the first COVID-19 vaccines came out, right? Because people were really wondering, what is an mRNA vaccine? Or how did scientists come up so fast with this vaccine? And now it's a little bit shifting, or at least here in Germany, now people have more confidence in those vaccines and they're actually looking forward to get them. And that's a good sign. And I just read an article yesterday about vaccination jealousy. So people are now jealous if someone else already got vaccinated. So
I definitely can relate.
Yeah, me too. Me too at this point. But let's just assume now everybody gets vaccinated. What is really important now is to figure out how long does immunity last. And right now it looks like immunity with the COVID-19 vaccines lasts around 6 months. So that means if someone got vaccinated in January, in June, probably that person has to get a booster shot, right? Or it's losing immunity. And I might not even be vaccinated in June, right? So there's this huge gap, right? And I think that's also a good point now. So we should talk about, because it always pops up, like herd immunity, right? That means when 70% of the population is actually vaccinated or is immune to a certain pathogen, in that case, the virus. And if we have around 70%, then basically the virus has no breeding ground anymore to flourish, right? And herd immunity depends on quite a few factors. It's quite complicated to calculate that. And one of them is the efficacy of the vaccines that are out there. But most importantly, it depends on the reproduction number of the virus, which is a measure for how transmissible, or in other words, how contagious the virus is, right? And this is where the new variants come into play, because they are more contagious, they're more transmissible. And that means we will reach herd immunity much later. And that is a real problem. So at this point, some scientists even argue we won't reach herd immunity at all with that virus. And to sum it up, the reasons are really factors like vaccine hesitancy. Not everybody will get vaccinated. On a global level, we have a very, very slow vaccine rollout. Then what I just said, we have this fading immunity over time, regardless of it's a natural infection or if you have immunity because of a vaccine. And then you have this emergence of those more contagious variants, which is a serious problem. And all of this means we're really in for the long ride with this pandemic.
Yeah, it looks like it. Just on a comment from my side, because we also believe that this is that from the way to normalcy, we need bridge solutions. That's why we build back together. But for these health certificates that come up, I think because of there is this vaccine hesitancy, and we have to respect it because it's in the end people's choice. All these health passport solutions should have the ability to not only be vaccine passports but be health passports, like could be including tests, like just if somebody doesn't want to take a vaccine, sure, they're free to do that, but still they have to be respecting the freedom of other people to not be transmitted with COVID. So they have to they must take a test for some places. So that's the logic behind our, at least, health passport solution, and I think it's a more broad one. So, but back to this very worrying prediction that you made, but makes a lot of sense on where you are basing it, that we are in for the long ride. So what about these mutations? Could you talk about why are they dangerous, and more about them, how they happen?
Yeah, so I mean, mutations are a serious problem, right? And I mean, of course, they can make COVID-19 more severe. But as I already said, the virus could just be much more contagious. And all of that means it's extending the pandemic significantly. And what's really important to know is that the larger the pool of infected people is, so the more people have SARS-CoV-2, the higher the chance that some new variants emerge. And that's just really simple because the virus has more opportunity to mutate, right? More breeding ground, in other words. And if those mutations occur at the spike protein, I think you probably know, right? The little spikes that stick out of the coronavirus, that can render the virus more contagious or impair immunity. Or worst case, the vaccines could become, or the virus could become resistant to the vaccines. And then also, actually, the immunity in a population itself can be a big problem because it's creating what's called selective pressure on the virus. So if you have a population with high immunity, because people were naturally affected or got the vaccine, then the virus has the selective pressure and would favor variants that are able to infect people that have already been immune to the previous strain. So that also kind of like accelerates those new variants that are more contagious. And so to sum it up, we are really right now in this constant race with this virus. And one solution would be a super, super fast global rollout of the vaccine, but that's not impossible. And that's really why we have to look to other solutions like digital solutions that help us keep this level of or bring back that level of normalcy, actually. And talking a little bit more about the variant. So we already know we had the UK variant, we had the South African variant, we had the Brazilian variant. And what's in the news right now is the Indian variant, right? It's really heartbreaking to see what's happening in India right now, that people are dying in the emergency room and no one can help them anymore. And that Indian variant carries what's called escape mutations. So there are 2 escape mutations in the spike protein of that variant. So that means it's much easier for the virus to escape basically the antibodies that have been elicited by the vaccines, right? And on top of it, the virus is just much more transmissible. And so we will see more and more of this variants popping up. And actually, I read recently about another variant, and that has been first identified in Angola, and it's now popping up in Tanzania. And that is a highly, highly mutated variant. So it has more mutations than any previous strain, and 14 only in the spike protein. So researchers right now don't know what that means, but it's a good example that, there is this pressure on the virus. We have this large pool of infected people, and that will just spur the development of more and more variants. So in my opinion, this pandemic will really go on for a while and will cost lives and will really cause also, economic damage. And that is a really, really huge problem on the long run. And, I think governments are doing a good job, right? Going into lockdown certainly helps, but it's not a long-term solution.
Yeah, what about the implication to the mental health as well? So it's not only physical well-being, health is both.
Yeah, and that's an extremely important point. And as I just said, those lockdowns have tremendous effects on all of us. So, but just in general, the virus has really turned our lives upside down, right? People lost loved ones, people lost their jobs, their businesses. And then a lot of people who have been infected with COVID-19 have those, what's called long COVID. They still suffer from some symptoms, even that they're actually healthy again. And I just came across this term again, and I don't know if you are familiar with that. And that's, it popped up around 10 years ago, and it said, we live in VUCA times, like VUCA, like VUCA. I don't know if you know that. You probably know that term. Okay. So V stands for volatility, U stands for uncertainty, C for complexity, and A for ambiguity. So, and I came across the term, for many years, and I was always wondering, what does that mean? My life is completely predictable and stable. But now with the pandemic, we really live in those VUCA times. Nothing is predictable anymore. Nothing is certain anymore. We have this high level of complexity suddenly just to live our normal lives, right?
Absolutely.
Yeah. And one thing in particular that's really hard on people is the isolation that comes with this pandemic, right? The social distancing. the children that cannot play with our kids, the teenagers that are there and they want to explore the world, but they can't. And then also elderly people. As I said earlier, they're very, very susceptible to any infection and they already suffer from loneliness. And then if you put isolation on top of that, that has tremendous health effect on people. And then, of course, the frontline healthcare workers who really, in my opinion, carry the biggest burden of this entire pandemic. So what is predicted currently is that this pandemic will have the same effect on people as any past natural disasters. And what we have seen after past natural disasters was we saw an increase in substance abuse. We saw a post-traumatic stress disorder, PTSD, and we saw a steep increase in depression. Yeah, and the first numbers are already out there. They have done some surveys in the US, and they saw that depression actually tripled over the course of the pandemic. And in other countries, numbers are quite similar. So this is very, very concerning, actually.
Yeah, absolutely. So we definitely have to think more intelligently than enforcing only horizontal lockdowns after this has been going on for a year. In the beginning, it was probably a good solution until we explore more of this virus. But I think the data are there. Some experiments have been done. Even people have been done in pilot events where people were going there with a test and no transmission was happening. So there are ways that we can avoid these mental health consequences and these economic consequences as well, or at least minimize them. While we keep everyone safe, of course, that's the first priority. So a question that I want to ask you is like, how has working on this project changed the way that you live your normal life? And what advice would you recommend to our listeners?
Yeah, overall, the last year just made me much more humble. The first thing I realized how little we know about science, how little we know about the immune system, right? Coming back to when we started the podcast, when I said we still don't know why some people get sick and others don't. And it will take some time to figure out how the immune system operates. And it's really this big puzzle, and we have to figure out every piece of the puzzle that's called immune system. And that will take a while. And the other thought that comes to my mind is that, we as humans always think we're superior, right? And we can control everything. And I think the pandemic was a great lesson that we cannot control everything, right? We do live in this ecosystem with, and I want to emphasize with, viruses, parasites, bacteria, animals, and plants. We're just all belong to this one big ecosystem. And we as humans, we're just not superior.
We should be friends.
Yeah, we can. Yeah,
absolutely.
And so I think for the future, what is really important is that big topic of climate change. So we really have to tackle that as a global community, not just individual countries, really as a global community. And we have to raise our children with much more environmental consciousness, right? I think those are really the key things for the future. And to end us on a positive note, the pandemic has brought a lot of hardship, but humans are very creative and innovative, right? And as I said also in the beginning with the Human Vaccines Project, you can turn obstacles and roadblocks into new opportunities. And this is really where I think of your startup, right? The pandemic really spurred your innovation, and you're doing a great job and trying to help everyone, live a better life with this pandemic. And this is really great. So thank you for that.
Thank you so much. You are obviously trying to do the same. And also, yeah, it's let's bet on human ingenuity to change our way of life, to be more respectful for nature. And if this might be a very good combination and a weapon against all these natural disasters. So thank you so much, Claudia, for this. It was not just insightful, it was enlightening conversation, at least for me. I'm sure about for many of our listeners as well. Yeah, these are topics that definitely should be discussed more, especially the relationship with the climate change, which I'm surprised that it's the first time I hear it, or while this should be a main topic of discussion. So one more reason to tackle the climate change. Mm-hmm. And thanks so much again. It was a pleasure.
Yeah, thank you. Thank you as well.
Please join us for our next episode to discuss the use of blockchain technology to support events in the face of COVID-19. We'll be joined by 𝗪𝗵𝗵𝗪, founder and CEO of Tickets for Good, to discuss the need for health passports in order to safely restart live events. See you all soon.